The other piece that I've learned is that you can't, as hard as you try, you can't code around human stupidity. You can try really hard, but just at the end of the day, it comes down to like, if someone wants to make a mistake, they're gonna make a mistake. Like my worst day was when an operator decided to dump a bag of one ingredient into the wrong tank and ruined a whole bunch of product, and that was like $1.2 million down the drain.
Welcome to the podcast today. We have Jake Magid with us. So tell us a little bit about yourself, Jake.
Grew up in Southern California, outside of LA in a suburb. Went to school at UC Berkeley, double majored in bioengineering and physics, and spent most of my time outside of class in the marching band playing snare drum. And then worked for a biopharmaceutical company for 3.5 years in a number of different roles, but primarily automation engineering. And now I'm at Cornell Tech with your lovely host Brett, and majoring in computer science.
You're in automation in biomedical device manufacturing? Or
it's not device, it's pharmaceuticals, yeah.
So what does that entail? Like, what does that mean?
Okay, so well, devices are actual like physical devices that you would use for a given medical purpose, and then there's the world of pharmaceuticals, usually small molecule and large molecules. How's that broken out? The small molecule is stuff that's like chemically manufactured, so ibuprofen.
Okay, it's like
whatever.
What's inside the pill?
Right.
Okay.
Well, yeah, what the actual medication is. Large molecule is stuff that you can't just like make in a lab because it's really complex, and that's normally like proteins. I worked at a place that fractionated human plasma to pull out target proteins that would be used in different medications, everything from hemophilia to immunodeficiencies.
Cool. So when people go donate blood, they donate plasma. Is that where you get it from?
We can recover it from donated blood, but there's also plasma facilities. It's actually a bit easier for you to donate plasma because you don't like feel lightheaded or anything after, because they recirculate your red blood cells.
So you worked in both large and small molecule?
No, it was only large molecule.
Only large molecule,
yeah.
Which is cooler than small molecule because you need like cool automation and cool machines to do it.
I mean, you have automation in most parts of manufacturing. The product is a bit more sensitive because it's a protein. It can denature. It's very...
You break down.
Yeah. You got to keep it at the right temperature, right pH, blah, blah, blah.
Okay. So what was your role involved with these automation of pharmaceuticals?
The whole process of starting with human plasma and ending up with specific, like, concentrated fractions of the plasma is automated through a bunch of big tanks and pumps and valves and blah, blah, blah. And it's usually a process of sort of adding alcohol and changing the temperature and centrifuging and then running it through a filter press and then
What's
purifying it then. Spinning it around so like the heavy stuff
separates out.
Heavy stuff goes outside. Not so heavy stuff.
And so what was your part in that? You were like managing all that, or like making it efficient, or making sure stuff didn't break down, or? Yeah,
so it would be to code the software behind all of that process that would run it. And so it would involve minimal like operator interaction, even though there's still parts that do require operators, but spinning up a centrifuge and adding the cooling liquid and adding any alcohol or whatever, that's all automated. And so I wrote the stuff that would do that.
And what software does that use?
It's called Delta V.
Delta V.
It's made by Emerson. It's like pretty popular within that whole realm. They use it at everything from like oil and gas to breweries.
Okay, so any like automated machines,
like big, large scale, yeah.
Cool. And so that's like mainly what that's used for, that software. Is it like most similar to something like Python or anything that stands out?
No, it's a bit different. Like, yeah, it's a totally different world. There's like sort of like 5 ways to program, and the main way is called structured text, and that's what we know. We write text. But there's everything from ladder logic, which is what is used in PLCs, and then there's sequential function charts and functional block diagrams. Those are 2 more. There's a 5th one, I forget it. Delta V involved a little bit of structured text, but was mainly sequential function charts and functional block diagrams. And so it was like, it's kind of similar to LabVIEW. I don't know if you've ever had to use that.
No, I've used that.
Yeah.
So Yeah, so like I guess you see all your machines on there, and you can like set up timers and like what they're actually doing, and inputs and stuff like that.
Yeah, you have device tags, and you normally correspond those specific bits on that controller to a tag that's in the software, and then be able to manipulate the output of that tag or the the input or whatever.
Are there any crazy stories of like bad code or a bug that like too much alcohol in it, or like the machine broke, or what's like the craziest one with that?
I don't know. There's like whatever can go wrong will go wrong. That's what I've learned.
Yeah.
And like the other piece that I've learned is that you can't, as hard as you try it, you can't code around human stupidity. You can try really hard, but just at the end of the day, it comes down to like if someone wants to make a mistake, they're gonna make a mistake. Like you can't do too much safeguarding.
How do they make a mistake when it's automated?
Sometimes there are manual additions to a tank. It's just easier to dump a bag of something into a tank than it would be to build in a whole like pump system, especially when it's like a solid ingredient. Really difficult to maintain all that equipment, and it's just sometimes easier just for specific process steps to dump a bag in. Like my worst day was when an operator decided to dump a bag of one ingredient into the wrong tank and ruined a whole bunch of product, and that was like $1.2 million down the drain.
That's a lot.
Which was,
yeah.
Rough.
Did you get any blame for that, or was it?
No, I mean I was involved in the investigation, but it, like at the end of the day, it says dump it into this vessel, and they chose to dump it in the other vessel.
Did the guy get fired over it?
He didn't. I mean, I don't know. They sometimes fire people, but normally they fire for safety stuff, like if you weren't being safe, but
not losing over $1 million in one
yeah, game. that was a new change to the process, and he was like one of the first to do it, and he just messed it up.
Interesting. So what like percent of the processes were like automated by your code versus people having to interject?
75% automated.
And is it make it a lot harder when people are like you have to like factor in those steps, like
you sort of have to just like really understand the process to be able to automate around it. Everything from like if you harvest a centrifuge bowl, it involves operators like taking paddles and scraping out the paste. And so usually that'll just like resume the automation process with them answering a prompt like, yeah, I did that, or like this is how much paste came out, or something like that.
Yeah.
And so
cool.
it jumps in and out of being totally automated to.
And what's the process like for creating automation code? So I'm used to like startups where you have designers and front end, back end. Like who are you working with in order to create that code?
It's really just me. There's a team of people that do what I do and will like peer review each other's code, but everything from like how it displays on the graphics to what it's actually doing to linking new devices with tags, like to all the hardware components of it, like it's pretty hardware involved. That was all within the realm of my responsibilities. So if there were any changes that needed to go in, like we would code those and then peer review each other. We had a sim system. It wasn't the greatest, but like you normally work on the sim system to get it up and running and then download that onto the production system.
Cool. And so but were there like scientists who came up with the procedures that you had to code after, and did you interact with them at all? Where like, this doesn't look right, or we can't do this? Most
of the projects were very cross-functional. I mean, they would come up with little optimizations here and there about like, oh, well, if you can add this much alcohol, or like you don't need to mix at this step. And so some of that would be pretty easy to change, but the big process changes would involve a whole team of people. But at the end of the day, like they're the ones telling me how the process should be, and I'm the one translating that into what the automation is going to look like.
Cool. Yeah. Awesome. Can you work at home at all with that, or is that you have to? Yeah.
You can. It's not ideal. I don't know. It's an old school business, so they're not used to that.
So is there room for disruption with new technology, do you think, or new software? Anything like
Always, yeah. I mean, I'd be able to log on to the production system remotely, but that's always really dangerous because I could just open a valve at some point.
And
so it's just
like control it.
Yeah.
So
that's a frightening thing, right?
Yeah.
A pressurized tank, I just like open a valve and some operator's working on there. It's like, it's a real safety risk. You have to really understand what you're doing.
Do you have to write tests at all for that code?
Yeah.
Yeah.
It's an FDA regulated industry. Huge test plans, change control, all that shit.
Because you're back in school, master's in computer science. Is there like a goal that you're moving toward with that? Like why go back?
I felt like automation helped me understand like my passion for like technology and seeing it work in the real world, but I wanted to dive a little deeper than the realms of like Delta V and manufacturing automation. And I've always been interested in computer science. I decided I wanted to sort of pivot into something software engineering or data science, or just learn a new set of skills that would allow me to build things, and like that's really cool to me. So I'm still trying to figure out what exactly I'm trying to do with my life, but
most people are,
here I am.
Awesome. So is there anything, like, since being here, like on your journey discovering what you want to be able to build, is there any sort of technologies or genres that piqued your interest?
I am spread across too many things. Like everything interests me still at this point.
Yeah. Like drones to crypto drones to...
I don't know. Like, yeah, everything from blockchain to like cryptography to data science, machine learning, to just like core software engineering skills.
Yeah.
It's all, I feel like it's all cool.
And do you see ways of like how automation can play a role in all those things? Like you see, like from what you learned there, that isn't, because people have different backgrounds, right, of getting into data science or crypto and stuff like that. Do you see like where automation plays a role in any of those?
I mean, the automation that I'm coming from is a bit different than I think automation in the software engineering context. Like normally it'd be like automating tests of your code, but that's not exactly what I would do. I think there's actually a pretty big gap between software and hardware. Just, I mean, in general, like we become so good at writing code to do certain things on computers, but like in my experience, automating valves and like pressure sensors, and you learn about a whole host of other problems that maybe have nothing to do with your code, but the way that the actual piece of equipment works, or like how it's been used. And so at least in the manufacturing context, there's a pretty big gap between people that know how to write code and people that understand field equipment.
Right.
And I would imagine that, maybe not so much for like, internet-based companies or SaaS, whatever companies, but companies that have an actual product, that there's probably a gap between how their hardware works and what their software is doing to it.
That makes sense. Yeah, have you messed with like the Internet of Things or Arduinos or Raspberry Pi?
Yeah, I play around a little bit.
Yeah.
With those, yeah.
Do you have some of those?
I have a Raspberry Pi.
What have you built with that or messed around with that?
I made a game emulator, like an N64 emulator.
Cool.
Playing like Super Mario. And then I tried to make like a Wi-Fi sniffer thing with Kali Linux, and like was trying to like crack my own house Wi-Fi.
Like you can like log into that network?
Yeah.
Did it work?
It works. It's contingent on
knowing your password.
on the Wi-Fi password being in a list of like, so say like the RawQ password database. Like if it's really good and like it's not on a common list of passwords, it won't find it. But if it is there, then it will find it. And it's like,
so it's basically like brute forcing.
Exactly.
Passwords.
Yeah. Like it can get the right whatever hash, and like.
Have you gotten free Wi-Fi places? Like
no, I haven't really tested it outside.
Brought it out with?
No. Yeah.
No Kickstarter campaigns.
Yeah.
All right, awesome. Well, thank you, Jake. It's been great having you on the podcast. Very interesting stuff about automation, pharmaceuticals, technology. So we really appreciate it.
Yeah, good to be here. Thanks, man.
Wow, you did it. You listened to the first ever Style is Free podcast. But don't stop there. Keep listening to more episodes. Binge all day, all night. Get through them all. Once you get through them all, there's going to be more coming, because we don't stop, won't stop here either. We're going all the way. Chinatown, hometown, New York City, LA, San Francisco. We're going everywhere. Non-stop, baby. To the top. Here we go. Keep them coming. We love your support. Thank you so much for listening to the Style is Free podcast. As always, I am your host, Brett Leibowitz.